Okay, so this is the practice exam number 3, practice exam version number 4, okay? And I went through in a separate video identifying or having you or helping you identify that this is an independent samples t-test, right? So we have some key pieces that help us identify that. So the independent samples t-test, that was chapter 10, okay? For us, that was chapter 10. And we're going to now go through and compute the full 4-step hypothesis testing procedure first, and then we'll come back and we'll do R squared. So the first step of the hypothesis testing procedure is that we need to identify or come up with our null hypothesis and our alternate hypothesis. For the independent samples t-test, here we're looking at a two-tailed test, so we need that part before we can create our hypotheses, okay? So in the independent samples t-test, we are comparing mu1 with mu2, okay? It is a two-tailed test, so the alternate does not equal, and the null just has equals. It's not specifying any direction. It's a two-tailed test, so it could either increase or it could decrease. Another way to write these hypotheses are to take everything over to one side. So if we subtract mu2 from both sides, we do mu1 minus mu2, and mu2 minus mu2 is going to be 0. And then the other version of the alternate hypothesis, mu1 minus mu2, does not equal 0. Step 2, we need to find our critical values, okay? So the critical values, in order to calculate those, or to, I suppose instead of calculate, it's to find those, we're going to use table B2. Table B2 requires that we know whether we're dealing with a one-tail or two-tail test, requires that we know our alpha level, and that we know our degrees of freedom. Based on the question, we know that we have an alpha of 0.05. We know that we have a two-tail test. We need to calculate our degrees of freedom. Degrees of freedom for an independent measures or independent samples t-test is n1 plus n2 subtract 2. So we have 12 plus 12 subtract 2, which is 24 minus 2, which is 22. Okay? And we need to find our critical values. We're going to have an upper bound and a lower bound, right? Because it's a two-tailed test. So if I come here, I have 22 degrees of freedom. It's a two-tailed test with an alpha of 0.05. Yep. So I'm going to come down in this column and I'm going to come across, and my critical value is right here. It is plus or minus 2.074. That plus or minus is important. It tells me that you know that there's an upper and a lower bound here, right? So there's negative 2.074, positive 2.074. Anything that falls out here or out here, we're going to reject the null and accept the alternate. Anything that falls in this middle area here, we're going to fail to reject the null hypothesis. So set that to the side. Now we need to calculate our test statistic, step 3, right? We have equal sample sizes, so we don't need to calculate our pooled variance. And we're going to bypass that because, I mean, we'd need the pooled standard deviation if we were asked to calculate Cohen's d. but we aren't. We are asked in this particular question to calculate r squared. So we're going to bypass calculating the pooled variance. What we are going to do, we are going to calculate the estimated standard error. And to calculate this, we take the variance of group 1 divided by n1 plus the variance of group 2 divided by n2. Except we don't have variance. We were given sum of squares. So we need to calculate the variance of group 1 and group 2. The variance s squared is sum of squares divided by degrees of freedom. So the variance of group 1 is sum of squares of group 1 divided by degrees of freedom of group 1. The sum of squares of group 1 was 429, and our degrees of freedom for group 1 is n1 minus 1, which is 12 minus 1, which is 11. And that'll be the same over here because our sample sizes are the same. So the sum of squares of group 1 is 429 divided by 12 minus 1. 429 divided by 11, which is 39. And I will put that up here. Okay, so I still have more to do, but I can put 39 divided by 12 plus, and now I need to do the same for the variance of group 2. So I'll take the sum of squares of group 2 divided by degrees of freedom, group 2. Sum of squares of group 2 was 396, and I will divide that by 12 minus 1. So 396 divided by 11 is 36. So here I will have 36 divided by 12. 39 divided by 12 is 3.25. And 36 divided by 12 is 3. So I have the square root of 6.25, which is 2.5. Now I can use this value to calculate my t. This looks complicated, but this cancels out to 0. It'll always cancel out to 0, and that's one of the reasons why writing the hypotheses in this way was helpful, even though, you know, these are equivalent. This was helpful because it helps us visualize and see why it is that in this formula this cancels out to 0. The mean of group 1 was 61. The mean of group 2 was 55. And then this estimated standard error is going to come down here. 61 subtract 55 is 6. And then we divide that by 2.5. And that is 2.4. Okay? This is step 3. Step 4, I'm going to put back over here because I can use this piece right here as part of my evidence for step 4. I'll put it in a different color for step 4 so that it's visually easier to discriminate. The value we calculated is 2.4. That was in step 3. And it's in this critical region here. It's beyond the boundary, the critical value. So that means we are going to reject the null, accept the alternate. There's a statistically significant difference between the two groups. The evidence can either be this right here that we've already drawn, or if you didn't draw a picture or you want to write it out, see it a different way. 2.4 is more extreme than the critical value. Okay, or you could say that 2.4 is in the critical region. You could say that 2.4 is larger than 2.074. So you got a couple of options there. Okay, that's A. Don't forget to come back and do B, the effect size measure. Okay, so for the effect size measure, this one is asking us for R squared. Okay, here, I'll scoot it up a little bit. So R squared equals T squared divided by T squared plus the degrees of freedom. And in this case, the T that we need to put in is the T from step 3. So we need 2.4 squared divided by 2.4 squared plus 22. That's the degrees of freedom that we originally calculated in step 2 of the hypothesis testing procedure. 2.4 squared is 5.76. So we get 5.76 divided by 27.76. Which is 0.21. That's a medium effect. A large effect would be 0.25, and this isn't that large. It's slightly smaller. Okay, so this is still medium.